Welcome to solverfy.
So here we need to find the density of the density of Jupiter to the density of the Sun, and then the density of Earth to the density of the Sun. So the ratio between them. So we can say that the force of gravity on Venus would be equal to the force centripetal for Venus. So we can say that G times the mass of the Sun times the mass of Venus divided by the radius of Venus's orbit squared will equal the mass of Venus times the velocity of Venus squared divided by the radius of Venus's orbit. So we can say that this is going to be equal to mv times 2 pi r VO divided by the period of Venus squared divided by the radius of Venus's orbit. And so we have that GMSMV divided by RV sub O squared equals 4 pi squared times the mass of the Venus times the radius of Venus's orbit divided by the period of Venus's orbit squared. And so we can solve for mass of the Sun, which would be equal to 4 pi squared times the radius of Venus's orbit divided by the gravitational constant times the period of Venus squared. So here the mass of Venus cancels out. And similarly for Jupiter, we can find that the Jupiter would be equal to 4 pi squared times the radius of Callisto's orbit cubed. Oh, my apologies. This is actually cubed. Divided by the gravitational constant times the period of Callisto. So Callisto is simply one of Jupiter's moons. So finding the distance between finding the radius of Callisto's orbit and knowing the radius of Callisto's orbit and knowing the period of Callisto, we can find the mass of Jupiter just like we found the mass of the Sun using information from Venus. So and lastly, we can find out the mass of the Earth by using the moon. So we can say 4 pi squared times the radius of the moon's orbit cubed divided by the gravitational constant times the period of the moon squared. So at this point, we can solve and say that for the ratio of the mass of Jupiter to the mass of the Sun will equal the density of Jupiter times 4/3 pi times the radius of Jupiter cubed. And then this will be divided by the density of the Sun times 4/3 pi times the radius of the Sun cubed. And so this is going to be equal to, we can actually get a new line, mass of Jupiter divided by mass of Sun will be equal to 4 pi squared times the radius of Callisto's orbit cubed divided by GTC squared. And then this will be divided by 4 pi squared times the radius of Venus's orbit cubed divided by the gravitational constant times the period of Venus squared. And we're going to relate this formula here to this formula here. And we find that the density of Jupiter divided by the density of Sun is going to be equal to the radius of Callisto's orbit cubed times the period of Venus squared times the radius of the Sun cubed divided by the period of Callisto squared times the radius of Venus's orbit cubed times the radius of Jupiter cubed. And we can solve, so the density of Jupiter divided by the density of the Sun. We're just simply plugging in for all of these values. This will be equal to 0.01253 cubed times 224.7 squared divided by 16.69 squared times 0.724 cubed times 1 divided by 0.0997, and this is quantity cubed. And we find that the ratio of the density of Jupiter to the ratio to the density of the Sun, rather, is 0.948. So this would be our answer for the density of Jupiter to the ratio of the density of Jupiter to the density of the Sun. Of course, the density of Jupiter is a bit less than the density of the Sun. After that, we can say that similarly, the density of Earth divided by the density of the Sun will equal the radius of the Moon's orbit cubed times the period of Venus squared times the radius of the Sun cubed divided by the period of the Moon squared times the radius of Venus's orbit cubed times the radius of the Earth cubed. And this is equaling 0.0036069 divided by 27.32 squared, rather, and then times 224.7 cubed divided by 0.724 cubed, and then times, again, 1 divided by 0.0109 cubed. And we find that this ratio of densities will be equal to 3.98. So we can see that the density of Earth is almost 4 times as great as the density of the Sun. And so this would be our second final answer. That is the end of the solution. Thank you for watching.